Hi everyone, I'm Anushka Ji, studying engineering at SVCE. Today we are gonna discuss topic in design analysis of algorithms. So I'm gonna start with the basic topic called the steps involved in analysis of algorithms and asymptotic notations. So in this PPT we are gonna study about different topics like steps involved in designing algorithms, algorithm design, algorithm analysis, asymptotic notations. In asymptotic notations, we have three subtopics called as big O notation, omega notation, theta notation, and applications of algorithm design and analysis. Steps in designing algorithms. Designing algorithms can seem like a daunting task, but it can be broken down into several manageable steps. The first step is problem definition, where the problem to be solved is clearly stated and understood. This involves breaking down the problem into smaller components and identifying the inputs and the outputs. Once the problem has been defined, the next step is algorithm design. The next step is to prove the correctness of the algorithm. Then we can analyze the algorithm. This involves coming up with a solution that solves the problem efficiently and effectively. Algorithm design. Algorithm design is a crucial part of creating efficient and effective solutions to problems. There are many different techniques that can be used, such as divide and conquer, dynamic programming, and greedy algorithms. Divide and conquer involves breaking down of a problem into smaller subproblems, solving each subproblem independently, and then combining the solutions to create a final solution. Dynamic programming involves breaking down a problem into smaller overlapping subproblems and solving each subproblem only once. Greedy algorithms involve making locally optimal choices at each step in order to find a global optimum. Algorithm analysis. Algorithm analysis is a crucial step in designing effective algorithms. It involves measuring the performance of an algorithm and determining its efficiency in terms of time complexity and space complexity. Time complexity refers to the amount of time it takes for an algorithm to complete its tasks, while space complexity refers to the amount of memory it requires to do so. By analyzing these measures, we can optimize our algorithms to run faster and use less memory, which is especially important in resource constrained environments like mobile devices or embedded systems. Asymptotic notation. Asymptotic notation is a mathematical tool used to analyze the efficiency of algorithms. It allows us to describe the performance of an algorithm as the input size grows larger and larger without getting bogged down into details of specific implementation. The most commonly used form of asymptotic notation is big O notation, which describes the upper bound of an algorithm's time or space complexity. Big O notation. Big O notation is a mathematical concept used to describe the upper bound of the algorithm's time or space complexity. It is important because it helps us to understand how an algorithm will perform as the size of the input grows. To calculate the big O notation of an algorithm, we look O function n power 2 plus n, we would simplify this into O function of n power 2. Omega notation. Omega notation are used to describe the lower and tight bounds of algorithms time or space complexity. Omega notation represents the best case scenario for an algorithm's time or space complexity, while theta notation represents the average case scenario. These notations are useful in determining the efficiency of an algorithm and can help in selecting the most appropriate algorithm for a given problem. Theta notation. Theta notation are also used to describe the lower and tight bounds of an algorithm space or time complexity. Theta notation specifies asymptotic bonds, both upper and lower, for a function f of n and provides the average time complexity of an algorithm. Applications of algorithm design and analysis. Algorithm design and analysis have a wide range of real world applications, from computer networking to learning and cryptography. For example, in computer networking, efficient algorithms are essential for routing data packets through complex networks. In machine learning, algorithms are used to train models that can classify data or make predictions. And in cryptography, algorithms are used to encrypt and decrypt sensitive information. Conclusion. In conclusion, through analyzing algorithms with measures like time complexity and space complexity, and using asymptotic notations like big O, omega, and theta, we can gain a deeper understanding of how our algorithms work, and how to make them better. Thank you, everyone. Thank you for watching this video. Hope you all understood.